So let's begin implementing a heap. So let's create a Visual Studio Code project. I'm going to create a project named heap here. Main program. I'm going to show how this works. So I'm going to include heap, class declaration, and some application code. I can create the heap and then do operations like on heap I can do push operation to store data, and then I can read a value from heap called the top. So top is simply to read the value at the root, which is the largest value, and then top operation will physically remove there. So that's what we are going to do. So let's create heap.h pragma once class heap. Again, here we focus on integer data type only, but you can change it to a template class to accept any arbitrary type though. Private, public, there. In private, the data are going to be stored in a vector. A vector is a flexible array, so you can add more capacity very easily. So instead of using generic array, let's use a vector for integer type, and let's call it elements in the heap. So for the vector, I need to include a vector library there. And for another private member would be some operations to find the left and right child parents and so on. But in public, we give the constructor so that we can create initialize the vector appropriately, and then destructor, and then void push is to add data into the heap, and then top is to read, and then eventually we are going to do top to remove the data and so on. And then let's give a size function which tells how many data are in the heap. Then let's define heap.cpp include heap.h constructor. The data are to be stored in vector elements, but recall the data representation. In data representation, we do not use the very first element. So let's give just the dummy data at the very beginning, which is not used at all, but we need to initialize it at the constructor. So elements, and then push back is the vector operation. Let's give a 0, which is unused at index 0. So that's the data representation in the heap we are going to implement for the algorithm. So for the time being, just destructor does nothing. If we do any dynamic memory allocation in implementation heap, we need to do something. Otherwise, we don't need to do anything at all. And then top function is simply to read the data. So when you read top, we return the value at index 1. So that is the one. So let me show you the data representation. So at index 1 is root 1. So we may want to assert that the size is always something, at least one element should be there. Otherwise, a top cannot be called C assert library. Then size function. Size function is a vector size -1, because the very first one we don't use, so that is the actual size of the heap. Like so, we need to implement the push, but the push operation is to find the, if you recall, push operation is add the data at the last one here and then compare with the parent and swap that. So we need functions to find its parent easily and its children easily. So let's give those functions in a private area, so which will be utilized internally inside the heap only, but it's not for public use. So let's give those ones int left child index given index. So we need this function as a helper function, and then we need to find right child index. Also, we need to find a parent index. Given index as a parameter. Where is a parent? The given index, where is the left child, the right child? So that's the helper function. And then also we want to read a value, not just index. So left child value. I am at index I, and then what is the value of my left child? What is the value of my right child? What is the value of my parent? So those are the helper functions we need to implement the push algorithm and pop algorithm and the like. So we have found those relationships here. So using this, let's implement one by one. So first, let's find left child index int heap. So left child index given index. I am at index. So what is the index of left child? So left child index is 2 times index. That's the relationship we found here. And then let me copy the code, paste, and then right child index is 2 times index plus 1. And then parent index given index. Parent index is index divided by 2, integer division. If we perform that, that's index of a parent. Now I want to read left child value, not index. I am at index, and then I want to read the value of my left child. Then index is known, then the value is at elements vector 2 times index. 2 times index is the index of the left child, then value is at elements vector. So there. Copy 3 lines, and then right child value is 2 times index plus 1, and parent value, if I am at index, is elements index divided by 2. That's my parent's value. And did I give everything? Index, 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 value, value, value. So I implemented all helper functions. Then I'm ready to implement a push function.